Hi, for those of you who don't know me, I'm Aaron Hurst, and this is the beginning of a one-sided conversation. You can make it two-sided if you want to leave some comments. I'm so nervous about this, guys. Hold on. Hi there, I'm Aaron Hurst. This is the beginning of a series of videos I wanted to make about my research, about an investigation that I've been looking into for the last 25 plus years, close to 30 years now. 37, I began when I was 9, so that makes it, 28 years I've been looking at this. Just dabbling into it, but for the last 2 or 3 years I've been really focused on turning it into a genuine scientific research project. I'm not a scientist, though I'm an amateur enthusiast. I do have a love of Earth, space, science, humans, humanities, travel through the cosmos potentially. So it's kind of all goes along with the idea of studying the Earth and finding more planets that are like Earth and understanding the history of Earth. And that's where I had a breakthrough that a lot of other people missed out on, is a key insight into the development of Earth's geothermal process. Truth be told, I didn't come up with it. I just read a bunch of material. One in particular that got me started was a book my grandfather showed me. It's really controversial, so I don't want to get into too much of the additional controversial material. So the main focus, like 90% of the book I tossed out. This 10% I really focused on was about the origins of the Earth and a claim that some of you are familiar with, others maybe never heard of, that the asteroid belt is the site where the Earth was annihilated. I didn't come up with it, I just furthered the research into it. So I don't want to take credit where I don't deserve it. But the claim is that the asteroid belt was the wreckage from the Earth being destroyed. The Earth was originally much larger, so large that it was able to have more than one moon. And the claim is also that the Earth was struck more than once. So things like Pluto being a lost moon is not really my idea, but I furthered the investigation and there's physical evidence that supports it, which I can demonstrate, or at least verbalize to you, and you can look it up yourself. So to begin it all off, was the Earth really struck? Was the Earth impacted? There's a lot of scientists that think that yes, the Earth was hit by a Mars-sized object, the theory called Thea, or hypothesis, because it's not proven. Thea hypothesis is about a Mars-sized object striking the Earth in such a manner, a perfect impact, that the moon would be formed from the debris. Because it's confusing why the Earth, a small, relatively small planet, has such a large moon. When you look at other planets like Mars, it has 2 moons that are really captured asteroids. We call them satellites more than moons. But so there's a confusion. There's a lot of confusion about where the Earth's moon came from and Earth's place in the solar system. There's a chart I studied for a year. I had it above my desk and I was just looking at it for a year. I put it together from 4 different charts about isotopes. The isotopes of the Earth, the isotopes, well, 2 different samples from the Earth, modern Earth and ancient Earth. From meteorites, which I suspect are not the building blocks of the solar system, but in fact are the debris from the exploding Earth. I mean, if the asteroid belt is made from the exploding Earth, then it would make sense that other asteroids, which formed at the same time, in the same conditions, are also debris of Earth, not the leftover building blocks of space, which I can get more into later. Yeah, I got so much material here to go over. I gotta try to keep it simple here and not lose my place. So, was the Earth struck? It was struck. Was the moon made from this debris? No, it wasn't. I can show this, I can prove this with these isotopes I'm referring to. I should pull out my chart and show you. But to put it in simple words, the entire Earth was struck by a calamitous force. So powerful was this calamity that the entire Earth's isotopes have been homogenized. When you measure them in parts per 10,000, the isotopes of 182 tungsten throughout the Earth, no matter which part you're sampling, are so homogenized that when you chart them, they fall between -1 and +1. While if you chart the moon or Mars, they fall between like a -7 and a +7. So the homogeny is not there for the moon, it's not there for Mars, and if we got samples from other moons and other planets, I would bet that they also would not be homogenized. While it's not only is the Earth homogenized today, but 3+ billion years ago, it was also homogenized. So the homogenization process of the Earth started a long time ago, possibly around 4+ billion years ago, 4.1 billion years ago. So the Earth is homogenized, there's no denying it. But how did that happen? And what kind of power does that take to completely homogenize a planet the size of Earth? There's so much into this. The power of the impact is recorded in meteorites. It's recorded in asteroids, but we can't get our hands on many asteroids. So the meteorites that we can get our hands on, that fall to Earth and we get samples of, they show that all meteorites, and presumably asteroids and comets, formed from 3 distinct formation events within a 5 million year window around 4.55 billion years ago. There's many reasons why that doesn't play along with the idea that the accretion disk created comets, meteors, and asteroids, but skipping over that for now. Excuse me for losing my place here, the absent-minded professor. So, comets, meteors, and asteroids are not the building blocks. We can prove it with isotopes that show... I'm going to have to pause for a second here, guys. It's my first one of these, so give me a second. Forgive me. The power of the blast. The power of the blast was so immense it was recorded in meteorites. Meteorites have minerals that are found in them, and only meteorites that are made of a special formation process, that's what I should say, that these minerals were formed in a process so extraordinary that we don't find any other moon or planet made of these minerals. So again, they don't fit the building block hypothesis. But these minerals, No! Oh, fuck me! And we're still recording. I lost the case, it fell off the top and landed on the top right corner. Here's where I get a better camera mount. That's what I get. What is it? No good deed goes unpunished, right? Check it out. The case fell off when it hit the porch. And then the phone fell a whole story without its case. Alright, we're gonna do the rest of this, wrap it up while I'm holding the phone. These minerals, calcium, I'm getting ahead of myself, chondrites, chondritic material. Chondrites are a special mineral that takes the shape of pellets. They are round, millimeter-sized globules that formed in temperatures that vaporized most material. The first of the 3 events was so powerful it created another very special mineral found within chondrites. This mineral is known as calcium aluminum-rich inclusions. And the special thing about CAI is that they flash vaporized tungsten and every other element in their formation process. Recreated in a laboratory, the calcium aluminum rich inclusions were when they're trying to recreate them and simulate them in laboratory conditions, they did a range of temperatures, a little higher, a little lower, trying to figure out exactly what was the right temperature that these minerals formed in. And what they found is that they formed at around approximately 0.86 billion degrees Kelvin. That's 860 million degrees Kelvin. To give you a good reference, the sun gets to about 15 million Kelvin at its hottest. So the 860 million degree formation temperatures is comparable to a neutron starburst, or just shy of what a supernova might do. You know, so very powerful stuff. So powerful you could expect that it would cause a tremendous amount of damage. I don't see why it wouldn't have caused further damage to the rest of the solar system, even. Well, in part it did. The late heavy bombardment, the debris that scattered chaotically all over our solar system, and the two asteroid belts formed from the explosion. So it was powerful enough to affect the entire solar system, but I guess it didn't, like, knock Jupiter out of its orbit or something. Which is what you might expect if a large gravitational source, something maybe like a neutron star, were to enter the solar system. So something as powerful as a neutron starburst struck the Earth, but minus the gravity influence. It's powerful enough to flash vaporize a planet, thus homogenization on a planet scale. But how powerful exactly are we talking about here? This was a quest, and I'll end with this here. This was something that I took a long time to discover and was very proud when I did all the calculations and finally figured it out. And I'll go through all the details right here for you. I was studying something else. I was studying the isotopes of tungsten 182 when I discovered somebody had calculated the amount of mass that was added to the Earth from the accretion disk phase. No, strike that. From the late heavy bombardment phase. They called it some other kind of accretion in the research to distinguish from the original accretion to the late heavy bombardment. Late veneer, that's what they called it. They didn't call it from the late heavy bombardment, they call it the late veneer, which is why a chance, or it's them attempting to explain and understand why continental shelves are so much thicker than the Earth's crust, was material added later, the late veneer. But what they did find out, because chondrites are only found in meteorites from the explosion, powerful explosion, because chondrites are only found in meteorites, when they're added to the Earth, their chemical signature can be detected. So not only was this detected in the Earth, but they also detected how much chondritic mass was added to the Moon and to Mars. And from these, I got an average of about 0.4, so less than 0.5% was, on average, accreted to the inner solar system. Now, that includes every planet, every moon, and the sun. Now, if you take that average and accretion rate of 0.4%, and every object in the inner solar system received an equal portion of their mass added to them of that average, that would include the sun, got 0.5% of its mass, less than 0.5% of its mass added to it. And to further back this up, if the Earth was much larger and exploded violently and scattered debris everywhere, the sun would be the thing that took up the most of the mass. The sun would be the thing that got hit more, that absorbed more. Other people have stated this. I made a simulation that also demonstrated it by proxy, not my focus on the scenario. But, so the average accretion rate throughout the entire solar system is less than 0.5%. And when you add that entire amount up, you can estimate what was Earth's original mass. Thus, it might give us a better idea of exactly how powerful that explosion was. I go over all the numbers here, but to skip ahead, because I don't remember it off the top of my head, the amount of mass that was added to the sun and the rest of the solar system. Now, one other thing here is we can only account for about 86% of fall meteorites having this signature. So if this estimate is incorrect, it's falling short of being incorrect, potentially by as much as 14%. So 86% accuracy. The amount of mass added throughout the entire solar system from the chondritic material that can be measured when compared to another object in the solar system is 4.22 times the mass of Jupiter. That's right. Earth was the biggest planet in the solar system. Earth was so big, 4 times bigger than Jupiter, you would plainly expect it to have more than one moon, in the natural way that big planets have more than one moon. So, I don't want to keep going, but let me end with the chemical signatures found on some of the lost moons of Earth: Sirius, Orcus, Chiron. The ammoniated sulfate recently detected on these are so similar, so chemically identical, that they somehow suspect Sirius must have been over by Pluto originally and drifted inward towards the asteroid belt. But they got it backwards. They're right, but they're backwards right. It wasn't Sirius that drifted from Pluto, it was Pluto that drifted from Sirius. Chiron, Sirius, and Pluto, and all the other lost moons of Earth were originally located at the asteroid belt before the Earth experienced 3 cataclysms that terraformed the Earth. It endowed the Earth with a supercharged geothermal core, which could last potentially 90 billion years, folks. Our planet could outlast 7 suns. But it also changed Earth's orbit, and that's really weird. And we're going to have to get into that in another video, because a planet being detonated 3 times, sure, cool, but being detonated 3 times in such a precise way as to alter its orbit, that's a whole nother level of weird, folks. So I hope you enjoyed this. This is my first one of these, so there was a little bit of roughness, the phone dropping, my just trying to get the hang of this whole thing. But the whole point of this is the information. The presentation of the information is important because it helps it get around, but more importantly, the information. So I gladly share this with you, and as soon as I get this published, which I've been working on for quite a while, I will share it with the whole world. So this is just my first step in sharing it with the world, guys. Peace, power, perspective, peace. Love. Bye.